These are the two topics which we will discuss. Topic number 1, that is clocks. In clocks, these are the concepts which we will discuss. Topic number 1, clocks. In clocks, the first thing is time period will be given. Time period will be given. Angle, we need to find it out. Right? Angle will be given. Time period, we need to find it out. These are the various types. If you study in a proper structured way, all these will be extremely clear to you. Imaginary clock concepts. These generally not taught in any of the regular textbooks. They use some formula which will backfire. Problems based on coincidence. Problems based on coincidence. And the fifth one is, right, watch gaining or losing problems. Watch gaining or losing problems. Watch gaining or losing problems. And the next one is mirror image. Mirror image. These are the 6 problems. Next is, if 10 minutes is extra added and everything, these miscellaneous problems. Once you understand first 6 key points, 7th one you can do orally. This is topic 1, clocks. All the concepts we will discuss. Topic number 2, which is calendars. Calendars. In these calendars, we will first discuss the introduction to calendar. What is a leap year? What is a non-leap year? How many extra days are there in leap year? How many extra days are there in non-leap year? Repetition of same calendar year. Repetition of same calendar year. Next we will discuss, right, how to find the day of any given year. These probably by the end of the class, if somebody asks you 15th August 1947, you will say that it is Friday and it will take less than 10 seconds to solve. Some problems based on odd days. Some problems based on odd days and some miscellaneous problems. These entire concepts which we are going to discuss for the next 120 minutes of time. Kindly do not leave the class in between, right? If you understand this, you will understand this, you will understand this. As some of you might be attending my classes, I will be using thematic based learning as a mechanism to explain the class. It is nothing but the world's best learning mechanism where a student will be able to understand every topic in less time and maximum productivity can happen in terms of the learning. Please take a screenshot of this so that you will come to know what is that I am going to discuss for the next 2 hours. Extremely important topic, especially for the students who are going to write placements, right? Very, very easy topic. Very simple to understand. Even if it is difficult to understand, I'll try to make it very, very simple for you. Kindly take a screenshot of it. Kindly take a screenshot of it. Are you all ready? Are you all ready? When you are listening to the class, say to the entire world, stop distracting from yourself from any of the external factors. If you are probably into any of the Instas or Facebooks and everything, 2 hours to give your time, I will give you 15 plus amazing concepts which will help you to maximize your score. Kindly reply with an yes in the live chat so that we all will begin with the topic number 1, that is clocks. Clocks and calendars. Very, very important topic. Kindly reply with an yes so that we'll start the class. Right. Please write down in the same order. Problems based on clocks. Problems based on clocks. Problems based on clocks. First one, introduction. A clock is in the shape of a circle. A clock is in the shape of a circle. Total angle in a circle is 360 degrees. So total angle is 360 degrees. There are total 12 hours in a clock. 12 hours is 360 degrees. 1 hour is 30 degrees. 1 hour, it is nothing but 60 minutes. 60 minutes is 30 degrees. 1 minute it is half a degree. 1 minute it is half a degree. That means we are only taking our hand as a point of reference. Our hand in 1 hour it will make an angular displacement of, in 1 hour it will make an angular displacement of 30 degrees. It will make an angular displacement of 30 degrees, and the same in 1 minute the our hand makes an angular displacement of half a degree. Half a degree. My only point of reference is our hand. Everything I did with respect to our hand. 12 hours is 360 degrees. 1 hour is 30 degrees. In 1 hour, if you see the clock, right? If you see the clock, 1 hour it is 30 degrees. 1 hour is 30 degrees, 60 minutes it is 30 degrees. 1 minute it is half a degree. I hope it is clear. This is the introduction. Now based upon this introduction, let us solve some problems. Type number 1. Write down in the same way. You don't need to refer any textbook after it. Just listen to my class. Type 1. Time period will be given. Time period will be given. Angle between hour hand and minutes hand needs to be determined. Sir, can there be seconds hand? That also we will discuss, but after understanding hour hand and minute hand. First question, 3:40 p.m. 3:40 p.m. This is the time period. This is the time period, right? This is the time period. Now just 1 minute, sir. I will take a wall clock so that it will be clear to you. Praveen, take the watch, Praveen. Find the time period between, right? Find the angle between the two hands of a clock for the time period 3:40 p.m. Now see here. Step number 1. 3:40 p.m. in a virtual. Now see here, sir. Thank you. Now if you see this is nothing but a clock. In this clock, total there are 12 hours are there. Total it is circle. So 12 hours is 360 degrees. 1 hour it is 30 degrees. So 12 to 1 it is 30 degrees. If the hour hand is moving from 12 to 2 o'clock, 12 to 2 hours it is nothing but 60 degrees. If the hour hand is moving from 12 to 6 it is nothing but a straight line. So straight line angle is 180 degrees. Or 12 to 6 it is total 6 hours. 1 hour 30 degrees, 6 hours it is nothing but 180 degrees. I hope through visualization it should be very, very effective. There are 2 hands in a clock. One is an hour hand and another is a minutes hand. Another important observation, 1 hour, hour hand will go 30 degrees. Minute hand will go half a degree. Hour hand in 1 hour it will go 30 degrees. Our hand in 1 minute it will go half a degree. Now if you see here, if you probably able to see here, the time is very, very closer to, right, 8:50. If you observe 8:50, the hour hand is at 9 o'clock and the minute hand is closer to 10 o'clock. There is an angle between these 2 hands. That angle between the 2 hands we have to determine. I hope it is clear. Step number 1. Forget about any formula. 3:40 p.m. First the hour hand is at 3 o'clock. Minutes hand is at 40 minutes, which is nothing but 8. This is not the exact time. Some changes needs to be done. That changes we will do it. Now see here. 3 to 8. How many hours gap is there? 5 hours gap is there. 12 hours is nothing but 360 degrees. 1 hour is nothing but 30 degrees. From 3 p.m. to 5 p.m. there are 5 hours gap is there. 3 5s are 50s are 150. There is 5 hours gap. That minute hand reached 8. That means it traveled for 3:40 p.m. means it is nothing but 3 hours, 40 minutes past 3 p.m. Am I right? This is the meaning of 3:40. 3 minutes past 3 o'clock. That means it traveled for 40 minutes. In our hand is actually initially at 12. 3, but it traveled for total 8. So 5 hours difference 150. So there is 40 minutes. In every 1 minute it will travel half a degree. So 150 minus half into 40, which is nothing but 130. Sir, why this minus came? If you observe closely, if the minute hand is at 8, our hand will not be at 3. Our hand will tilt for 40 minutes, some angle. 1 hour, 12 hours 360, 1 hour 30 degrees. 1 minute it is half degree. When it is at 340, our hand is at 3, minute's hand it is at 8. But when the minute hand reaches 8, our hand will tilt for 40 minutes. 1 minute half degree. So out of 150, 20 tilted. What is the answer? 130 degrees. 130 degrees. I hope the idea is clear. 4 to 5 problems which we will solve, then it will be extremely clear to you. 2:20 p.m. If it is 2:20 p.m., step number 1, our hand is at 2, minute hand is at 4. This is the our hand and this is the minute's hand. This angle I need to determine. This angle I need to determine. First, 2 hours 4, 2 to 4, that means 2 hours difference, total 60 degrees. But when the minute hand reaches 4, our hand will tilt for 20 minutes. 1 minute half degree, 20 minutes 10 degree, 60 minus 10. Answer is nothing but 50 degrees. No formula, nothing is required. 6:30 p.m. If it is 6:30 p.m., step number 1, represent it on a clock. Our hand will be at 6. Minute's hand also will be at 6. When the minute hand reaches 6, our hand will tilt for 30 minutes. 1 minute half degree, 30 minutes it is nothing but 15 degrees. I hope the idea it is clear. D. 4:45 p.m. Then E and F will make us learn some more concepts. 4:45 p.m. Our hand it is at 4. Minute hand it is at nothing but 9. So total 5 hours. 5 is nothing but 5. 30s are 150. 45 minutes it will be tilted. So half of 45. 150 minus 45, which is nothing but 127.5. 22.5, 127.5. I hope the concept is clear to you. 2:20 p.m. Our hand is at 2. Minute's hand is at 4. There is 2 hours difference. 2 hours is nothing but 60. When the minute hand reaches 4, our hand will shift for 20 minutes. 1 minute half a degree, 20 minutes 10. Out of 60, 20, it is actually like this, but actually it will become like this. So this remaining angle is nothing but 60 minus 10, 50. 6:30 p.m. Our hand is at 6, minute's hand is at 6. When minute's hand reaches 6, our hand will tilt for 30 minutes. Half of 30 is nothing but 15 degrees. This is nothing but 150 minus half into 45, which is nothing but 127.5. I hope it is clear. 2 more problems which we will solve. Then we will solve the problems orally. 2 more problems. 2:50 p.m. 2:50 p.m. Next is nothing but 10:10 p.m. Next is nothing but 10:10 p.m. Now here, let us discuss a concept of reflex angle. Reflex angle. Suppose if I take a circle, this is nothing but theta. There is one angle which is formed to other side. This is nothing but 360 minus theta. So reflex angle is nothing but theta is greater than 180 degrees. Theta is greater than 180 degrees. So by default, if he is asking an angle between an hour hand and minute's hand, he is referring to a non-reflex angle. He is referring to a non-reflex angle. That means we should get from 0 to 180. Suppose if he is asking what is the reflex angle, reflex angle means theta is greater than 180. So do 360 minus theta. Please make a note of it. When two lines intersect, This is one angle and it is nothing but another angle. So if this is a non-reflex angle, this will be a reflex angle. If this is a non-reflex angle, this will be a reflex angle. Total sum of non-reflex angle and reflex angle should be 360 degrees. Now 2:50 p.m. Now see here, sir. Now 2:50 p.m. Before discussing 2:50 p.m. and 10:10 p.m., let us go back to the question 3:40 p.m. In the 3:40 p.m., our hand is at 3. Our hand is at 3. Minutes hand is at 8. Now, our hand is chasing minutes hand. Am I right? Our hand is chasing minutes hand. If a minutes hand is chasing our hand, I will get a reflex angle. So here we will see 250 what is happening. The reason why I said this reflex angle is to discuss this question. 2:50 p.m. 2:50. Let us represent it on a clock. This is nothing but 2. This is an hour hand. And it is nothing but minutes hand. These 250, some changes needs to be done. So let us go with this change. Our hand is chasing minutes hand. 2 to 10, 8 hours difference. Each hourly angular displacement difference is 30 degrees. 8 into 30. When the minute hand reaches 10, our hand will tilt for 15 minutes. 50 by 2 minus half into 50. These are nothing but 240 minus 25, which is nothing but 215 degrees. Oh, we got greater than 180. That means the angle which we got is nothing but a reflex angle. We got is nothing but a reflex angle. But default, if he is asking the angle, it is nothing but the non-reflex angle. It is nothing but the non-reflex angle. Non-reflex angle is nothing but 360 minus theta. So 360 minus 215. Answer is nothing but 145 degrees. 145 degrees. Now a smart student might ask me a question. Hey Anil sir, instead of making hours hand chasing minutes hand, can I make minutes hand chasing hour hand? Yes, you can do it. Minutes hand chasing hour hand. 10 to 2. How many hours difference? Here there is 12. 10 to 11, 1 hour. 11 to 12, 1 hour. 12 to 1, 1 hour. 1 to 2, 1 hour. 4 into 30, 120. This is like this. Now, when it reaches here, it will tilt for 25 minutes. So, 120 plus 25, which is nothing but 145 degrees. 145 degrees. What did you learn from this question? If hours hand is chasing minutes hand, if hours hand is chasing minutes hand, it is subtraction. If hours hand is chasing minutes hand, it is subtraction. If minutes hand is chasing hours hand, if minutes hand is chasing hours hand, it is nothing but addition. Please make a note of it in your notebook. Right? If hours hand is chasing minutes hand, it is subtraction. If the minutes hand is chasing hour hand, it is nothing but addition. If you get an angle greater than 180 degrees, then it is a reflex angle. Take 360 minus theta. He will clearly specify in the question, right? Whether if it is a reflex angle, he will specify. If he is giving you angle, then means he is referring to a non-reflex angle. Non-reflex angle. One more question which we will do it. Suppose for example, F 11:10 p.m. If it is 11:10 p.m., this is nothing but like this. This is nothing but hour hand and it is nothing but minutes hand. 11 to 3. 11 to 3, how many hours? 3 hours. 3 into 30, which is nothing but 90, plus half into. This is nothing but 10 by 2, which is nothing but 5. Half into 10. So 95 degrees. 95 degrees. Again, I am repeating, don't do this mistake. If a minute hand is chasing our hand, if minute hand is chasing our hand, we have to add the angles. If the hour hand is chasing minutes hand, if the hour hand is chasing minutes hand, it is nothing but subtraction. It is nothing but subtraction. I hope this idea it is clear. G, one more question is left. These also you can solve. Suppose if it is 10-10, by just it is 11-10. So 10-10 means D is 10, D is 2. 4 hours difference, it is 120 plus half into. This is our hand and it is minutes hand. This is our hand and it is minutes hand. So here our hand is chasing minutes hand. When the minutes hand reaches to, sorry. This is nothing but, this is 11 to 2. It is nothing but 4, 3. It is 90. When the minute hand reaches to, it will tilt for half into 10. This is nothing but 85 degrees. I hope it is clear. 10 to 2, it is nothing but 120. If the minute hand is at 120, it is nothing but 120 minus 5, which is nothing but 115 degrees. Here I did a mistake of thinking that minutes hand is chasing our hand. No, here our hand is chasing minutes hand. So it is subtraction. Here also our hand is chasing minutes hand. It is subtraction. I hope you got the idea. I hope you got the idea, right? So don't do this mistake of if the our hand is chasing minutes hand. If the our hand is chasing minutes hand, it is subtraction. If these minutes hand is chasing our hand, it is plus. Here I wrote the point right, but in a hurry I did this. Don't be impatient while solving a problem. That is the lesson that you have learnt. I hope it is clear. Sahana, how you got 90 degrees? 11 to 2, 11 to 12, 1 hour, Sahana, 12 to 1, 1 to 2, each angle 30, 30 into 3, 90 degrees. I hope this idea it is clear. Vamshi, you are right. Tejaswini asked, do once again for 6:30, Tejaswini for you. If it is 6:30, if the hour hand is at 6, minutes hand also reaches 6. If the minute hand is at 6, our hand will shift for 30 minutes. 1 minute it is half a degree. Half of 30 is nothing but 15 degrees. I hope the idea is clear. Concept number 1. Is it clear? Kindly reply in the live chat in case if you got any doubt. Concept 1. I hope it is clear. Most likely it should be clear with no doubt. Concept number 1. Is it clear? Unnecessarily in some textbooks, R.S. Agarwal are the teachers who does not have an understanding of the deeper idea of the concept, you will use this formula. No reason to use this formula. I cannot mug up things. My mind is probably a very, it is not even TB. It is in MB. I cannot remember any formula. So within the limited capacity, I will try to learn as much as possible. Right? I hope it is clear. Concept number 1. I hope it is clear. Concept number 2. Please write down. Concept number 2. Imaginary clock concept. Concept number 2. Imaginary clock concept. These are some of the questions which I created for the mock papers. The question is, what is that angle between the two hands of a clock, hour hand and minutes hand, in an imaginary clock of 240 degrees? In an imaginary clock of 240 degrees. Assume there is an imaginary clock where the total angle is 240 degrees. What will be the angle between the two hands of a clock? So what I will do is, I will use the concept of virtual positioning. I will use the concept of virtual positioning. Virtual is nothing but an unreal. So clock is in the form of a circle. So, but the total circle, instead of 360 degrees, he gave it as 240 degrees. And there is no change with respect to our hours. So 12 hours is 240 degrees. These premise only, instead of 360, it is 240. 1 hour is nothing but 20 degrees. There is no change in minutes. So 60 minutes is 20 degrees. 1 minute is nothing but 1/3 degree. 1 minute is nothing but 1/3 degree. And put a star mark on these virtual positioning. I will explain what is this virtual positioning. 1 minute it is 1/3. Assume a circle with total angle to 240. It is an unreal representation. 340. These like this. Right? These nothing but hour hand. These nothing but minute hand. Idea is to tell you nothing will change. Now see here. These 5 hours. 1 hour 20 degrees. 5 hours it is nothing but 100 degrees. When the minute hand reaches 8, our hand will shift for 40 minutes. 1 minute it is 1/3 degree. So it is nothing. The only value will change. 100 minus 40 by 3, it is nothing but 260 by 3. So these nothing but 3 8s are 24, 86.66. Nothing I did, sir. Instead of 360 degrees, I replaced it with 240 degrees. And remaining everything remains the same. This is the beauty of knowing the concept. This is the beauty of knowing the concept. Suppose if instead of 240 degrees, he gave you that there is an imaginary clock of 24 hours. What you will do? Instead of 12 hours, it is 24 hours. These 240 degrees is question number 1. These 24 hours is question number 2. 24 hours is 360 degrees. 1 hour is nothing but 50 degrees. So 3 to 8. These 3, these 8. 1 hour is 60 minutes. 60 minutes is 15 degrees. 1 minute is 1/4 degree. 1 minute is 1/4 degree. These 5 hours difference. 5 is nothing but 75. 1/4 of 40 is nothing but 10. 75 minus 10 is 65 degrees. This is the beauty about the concept. This is the beauty about the concept. Total angle in a circle, instead of 360, it is 240 degrees. Instead of 12, it could be 24 hours. It could be 36 hours. Instead of 1 hour 60 minutes, it is in 90 minutes. Whatever that is there, change the premise. Change the premise. Change the premise values, you will get every possible question for an imaginary clock. This is where the logic will defeat the formulae. Formulae is derived from the logic. Logic is never derived from the formulae. I hope this concept number 2, this is a little cat advanced level. Probably for placements till now it is not asked, but idea is to tell you it is the same point of reference, sir. It is nothing but the same point of reference. Same point of reference. It is like these, like suppose if it is now Dilshad, if it is 315, this hour hand and minutes hand becomes the same. So these nothing but 12 hours is nothing but 240 degrees. 1 hour is nothing but 20 degrees. 1 hour is 60 minutes. 60 minutes is 20 degrees. 1 minute is nothing but 1/3 degree. So answer is nothing but 15 by 3. It is nothing but answer is 5 degrees. Idea remains the same. There is no difference in the way that you look at it. It is all about knowing the concept. Concept number 2. Because I said virtual positioning. What is virtual positioning? This is a very beautiful concept in geometry, sir. Virtual is nothing but unreal. Virtual is nothing but an unreal. So, by using this concept, you can solve a lot of geometrical problems in seconds. If anybody has taught you, consider yourself lucky. Otherwise, right, probably consider yourself unlucky. Now see here, I will tell you 2 or 3 problems so that you will understand what is virtual positioning. Just I am going 10 minutes off track of clocks so that you will understand what is virtual positioning. Suppose ABC is an equilateral triangle. ABC is an equilateral triangle. ABC, it is an equilateral triangle. In that one incircle is inscribed. Inscribed means the circle which touches the sides of a triangle. In that one, inside one triangle is inscribed. So, if you observe, the circle is touching the vertices of a smaller triangle, which will become the circumcircle. That circumcircle is becoming the incircle for an outer triangle. DEF is also an equilateral triangle. DEF is also an equilateral triangle. What is the area of this region to the total region? So, this is nothing but a area of DEF by area of ABC. Area of DEF by area of ABC. Generally, traditional method, what most of the students do is, because the teachers have taught them very beautifully what is a circumcircle, what is an incircle, they will use all this very neatly, step by step. These step by step very beautifully. They know the formula, they will solve it like the way we solve a 10th class problem, substitution, solving and everything, right? Such an emotional happiness in solving the question using formula based, right? So 2 minutes you will solve the question. This is the most stupid way of solving this question, right? Because you are not using your brain here. You are just using the formulas and you are solving it. A, B and C. See here, sir. This is nothing but an incircle. This is nothing but an equilateral triangle. Now see here. Suppose there is a water bottle, it is here. If a water bottle is shifted, I am there in my studio, it is in the shape of a cuboid. If I shift it from this point to this point, will the volume of the water changes? No. If I rotate this water bottle, right, I am worried that it will fall. So that is the reason I am not rotating. If I rotate it, then the volume of the water will not change if it is perfectly closed. That means if I shift it from one point to another point, or if I rotate it, the area will not change. The number of integral points will not change. Of course, the value of the critical point, integral points will change. If I shift it x plus x dash, y plus y dash. If I rotate it x cos theta minus y sin theta, y equivalent to x sin theta plus y cos theta. So, I will rotate it because the area will not change. So, this figure, I am rotating it like this. This is nothing but, if I rotate it like this, so I will do like this. See here, sir. Virtual positioning, it's very exciting concept, sir. If I rotate it like this, these are nothing but ABC. These are nothing but DEF. If I rotate it like this is a tangents drawn from an external point. Tangents drawn from an external point are always equal. Tangents drawn from an external point are always equal. Now, if you observe here, this is an equilateral triangle. So, that means this is 60, this is 60, this is 60. So, these two, that means this angle and this angle, both are equal. So, if it is both are equal and outside also it is given equilateral triangle, these 60, these 60, these 60, remaining to 120. So, each are equal. So, it is nothing but 60, 60. These nothing but 60, 60. These also nothing but 60, 60. These also nothing but 60, 60. Totally there are 4 equilateral triangles I got. Answer is nothing but 1 out of 4. Answer is nothing but 1 out of 4. This concept is what we call it as virtual positioning. Virtual positioning is assuming that if the figure is rotated, what will be the behavior of the graph? What will be the behavior of the graph? What will be the behavior of the graph? I hope the first question it is clear. I hope the first question it is clear.